Okay, so we almost finished everything with the example that we did on last Wednesday, and we created this Highlander application, and we did it in two different ways. We did it one way using validation, using only one try-catch block to validate all the input, right? The advantage of that is that it's simpler, right? So you put basically, let me start this thing, the projector. Okay, it's taking time. Okay. So with I may have to zoom in. Okay. So basically, we already know about you do step 0, right? Okay, which is, let me make sure it's zoomed correctly. Step 0 is you declare variables. And this is more like a template I use, and this is where you use the dim statement. And you declare for each variable, so we can declare integer variable as integer, and you can declare double variable as double. They also like to declare decimal variable. I like double myself, so it doesn't matter. You can use decimal if you like as decimal. So you do step 0 first, and then you do one single try block. And in the try block, you do step 1, which is the input. Okay, and this one basically you would use maybe int variable is equal to cint, and use maybe the text box. Remember, the input you input from a text box, txt control dot text, right? And if you have a double variable, you can put that dbl variable equals cdbl txt control dot text. Right. And the number of input statement you have is the number of the text boxes you have. So if you have a form that have 2 text boxes, you need 2 input statement. And then you do step 2, which is processing. This is calculation. This is where you do basically, you do variable equal expression. This is where you do your calculation, right? And you have step 3 is the output. Okay, and this is where you display the output. Maybe you'll have something like lbl control dot text equal I don't know, maybe numeric variable dot toString. And you can use format specifier if you like. All right, and this is, you put all of this, you put it in the try block. So you do the input, the processing, and the output. These 3 steps, you put them in the try block, and you put one catch block, and you will say E as exception. And this will generate it automatically by the system. As soon as you type try and press enter, it's going to give you the catch, so you don't have to type it. It just will Visual Studio will do that for you. And then all what you do in here is you put a message box with an error message. Maybe something like to say that numbers only. All right. So if you enter in here a non-numeric value for in the TXC control text box, you're not gonna be able to convert to an integer because it's a character, it's not number, it's maybe ABC, right? So it doesn't convert. This will throw it to the catch block, and you're gonna get a pop-up window saying enter numbers only, and this will be the end of try. So this is one way you can do that. You can just basically do your step 0 outside the try block, and then do step 1, 2, and 3 inside the try block, and put your error message in the catch block. The nice thing of that one, it's very simple. I mean, you can easily do it. You don't have to think about it. You can just do it easily, right? The thing that is not that good about it is that if you get an error entering the second in the second text box, it doesn't tell you where the error is. It tells you need to enter numbers, right? That's the only message you get. You need to enter numbers. What if I want to be able to tell me, all right, you need to fix the second text box and you need to enter number. Not only that, you want to maybe place the focus on that text box so the user can simply override the error with the correction. This one, you can do that by using multiple try block. So in this case, if you have two text boxes, you will use two nested try block, one try block inside the other. And this is how you do that. So let's go ahead and look at this thing, how we did that with this example. In this example, we had 5 text boxes, right? So we have the night, you have the nightly charge, you have this room service, telephone, and miscellaneous. So if you want to do custom kind of error handling, you want to use five nested try catch blocks to do that, one for each text box. And this is how the code look like, right? So basically, as before, you have step 0, you declare your variable. Again, for each input and for each output, you declare a variable. In our example, we had 5 input, these are the text boxes, and we have 5 output, these are the labels. We need 10 variables total, all right? And everything is money except the night. All of them are going to be double, except the night is going to be integers. And we declare them in here. So we have the night is declared as an integer variable, and everything else are declared as double, right? Notice the use of meaningful names. You call it DBL nightly charge, DBL room service, which come directly from the label. Nights, nightly charge, room service, telephone, miscellaneous, room charges. You take these things, you glue them together as a single name, and you name them. So this is the step 0. Now we're gonna do the input, but we're gonna do customized error handling. We're gonna try to input, instead of having just one step input, you can have multiple try for each input. Each try for one input. You try to input the TXT night. You do it in here. So you try to convert the TXT night to an integer and assign it to an int night. If it succeeded, you continue, right? If it fails, this will throw you to the outermost catch block, which is the last one in here. And this is you do customize error message. So the first one will give you the last one. The first try will give you the last catch, which is basically you would say customize error message, enter numbers only for nights, and you put the focus on the nights text box, right? And then when you go there, you select all the text in this text box so you can make the corrections, right? Now, if the input succeed, if you enter a valid value for nights, let's say you enter 2 nights, it's going to convert nicely to an integer, and it's going to be stored in nights. Then you try to input the next text box, right? So try to input the TXT nightly charge, right? Again, you try to convert whatever you enter in the text box to a double. If it fails, it's going to throw it to the second catch block from the bottom. So throw it to the second one from the bottom, and this is going to tell you enter number only for nightly charge, and this will put the focus on the nightly charge and select all the text in the nightly charge set box, and etc. Continue, right? If it succeed, it tries to do room service. If it fails, throw it to a cache block. If it succeeds, goes to the telephone. If it succeeds, go to the miscellaneous, right? If everything succeeds, then you would do the processing. So the step 2, which is processing, must be in the innermost try block, right? Not in the first try block, not in the second or third or fourth. It has to be in the innermost, all right, try block. You do step 2, and so is step 3 will be in the innermost try block. You don't put anything after the end try. You don't put anything after that. Between try and end sub, you don't put nothing, right? If you put something in here, and if you have an error, it's going to create a problem. So nothing after end try. Everything must be in the innermost catch block, in the innermost try block. So you put that. And when you do that, and if you run it, you're going to have custom error handling. So I'm going to go ahead and run it to show you basically what happened with this thing. And so I'm going to put in here an invalid value for nights, right? So you calculate charges. It's going to detect that. Enter numbers only for nights. So we say, okay, it's going to put the focus on the night field, and it's going to select the text. Here it is. I'm going to put here 2 nights. I'll put an invalid value for nightly charge. Again, it's going to detect that. Enter numbers only for nightly charge. It's going to throw it and select the nightly charge. I'm going to put in here maybe $70. If you leave a field blank, it's going to detect that also. They tell you enter number only for room service. It did detect there's nothing on room service. So when you say, okay, it's going to take you to room service, let's say $10. Let's put an invalid value for telephone. So again, it's going to detect that. So I'll put in here $2. And let's see miscellaneous blank. Again, it's going to detect, so you have to enter a value. If you have nothing, you have to put 0, right? Okay, so you have that, and then calculate charges. Here it is, right? So it gives you a better experience. I mean, it's a little bit more code, more work, but it's look much better than this thing, right? Than doing this one. This is simpler, but it doesn't tell you where the error is. The other one is more, you know, you're using more nested try-catch block, but give you better interface. Let's go ahead and stop this program. Right, so this is basically what we did last time. So we're almost done with examples. We're gonna do one more example. So I'm gonna go ahead and save that, and I wanna close this solution in here. All right, we'll do one more example, and this last example we're gonna do is we're gonna reinforce the concept that we covered, and also we're going to introduce something called debugging, the concept of debugging. And we're going to talk more about debugging in chapter 4, because this is where it's going to become important. All right, so they have this form in here that's going to take the finishing time of 3 runners and compute the average, basically speed, the average time. So this is just I already named the label. So this is named, if you look at the name feed, the common name, this is textbooks, TXT runner 1, TXT runner 2, TXT runner 3. This is a label, LBL average. So this is what I call them. All right, so I did it to program. This is BTN calculate. I will double click on this one. We are in the code window, and we can write our program. All right, so again, we're going to use the prototype that I explained to you. So again, you start with step 0 to declare variables, and for each input and for each output, you declare a variable. So if you look at your form, you have 3 input and 1 output. So we need 4 variables. Let's assume all of them can, let's say that the running time are integer, are whole number. They represent seconds. They're going to be whole numbers, and this is going to be a floating point number. It's going to be double, right? So we can declare this one. So the first 3 are going to be integer. So I'm going to say int, and I'm going to call in here runner 1 time. Okay, I have to say them. Always you start with them. So runner 1 time as integer, dem and runner 2. So each text box and each label for output will be, you declare a variable for it. Right, and we need one more variable for the label for the output. And this is gonna be DBL, it's gonna be double, average as double. Right, so you do that, okay? So step 0, you declare a variable. For each input, a variable. For each output, a variable. Now, what we're gonna do in here, we're gonna do the more, I'm not gonna do simple one. I could have done the simple one like this one. I can just put try and put the input processing the output in one try block. And in the catch block, do generic error message. But I wanna do something more, more custom. So it will tell me where the error is, right? So in this case, because I wanna do custom one, you're gonna do, you need 3 nested try catch block because you have 3 text boxes, right? Since you have 3 text boxes, you need 3 nested try catch blocks. So let's go ahead and do that. So I'm gonna put in here try, and that's all what you need to remember. The word try, press enter, is gonna give you the catch block. So the first try is you're gonna try to input runner 1 time. That's what you're trying to do. And the error message you're gonna get in here is for failure to input runner 1 time. So you're gonna put in here message box that show enter numbers only for runner 1 time. All right, so we'll put customer message that, right, the error is in runner 1 time, enter number only. And we're gonna put the focus on the control txt runner 1. So we move the cursor to that text box. And we're gonna select all the text in this txt runner 1. And this is you say select all. Right, and this is basically what you do in that. All right, now we can do in here. No, the select all is a method. That's why it adds the parentheses, right? If you don't put it, the Visual Basic will do that for you. Let's do the next one. All right. So each inputs need to have a try block. The next one we're gonna try to input runner 2 time. All right, it's gonna give you the catch block. Again, this one is gonna be for runner 2. I'm gonna copy that from here. And I'm gonna paste it here. Okay, I can just change runner 1 to runner 2. Right, so we have that, okay? And then we have one more. I forgot in here, after you do this try, sorry, the first one, you have to do the input statement, which is int runner 1 time equal cint txt runner 1 dot text. And for this one, you have to do also int runner 2. Sometimes my keyboard gets stuck. Runner 2 time equal cint txt runner 2 dot text. And then we're gonna do the last one. We're gonna try to input runner 3 time. Right? And again, this is we'll do another input statement and runner 2 time, runner 3 time equal to CINT convert to an integer txt runner 3 dot text. Now, if you fail, if you fail in runner 3 time, you will put an appropriate error message in here for runner 3. All right, so we put our program for runner 3. Now, only if all the 3 input statement work, this is you were able to successfully input runner 1 time, and you were able to successfully input runner 2 time, and you were able to successfully input runner 3 time. Only if you do all 3, then you put step 2 and 3 in the innermost try block. So this is where you're going to put step 2, which is processing, and step 3, which is output. All right. Now, step 2 is we're going to calculate the average, which is, this is your variable DBL average. So we're going to do DBL average equal. All right. And I may do some mistake. And this is the purpose of this example is I want to do a mistake on purpose to see how I can find the error. So I'll put in here some, try to complete the average, which is basically you need to sum the running times and runner 1 time plus and runner 2 time plus and runner 3 time, and you need to divide by 3. And I may be doing something wrong, just not worry about it right now, okay? And I'm gonna go ahead and put in here the output. I want to display the average. So I'll say in here LBL average dot text equal to DBL average dot toString, and we're gonna format it as number. This is not money, so I cannot use C like we did before. I have to use N. So this one, it's like C, but it doesn't put $sign. So N is same formatting as C. It put the comma separator if you have thousands, but it doesn't put a $sign. So this is basically the program, right? So it's gonna do that, but it does have a logical error, right? And this is what we're gonna do in here. So let's go ahead and run that and see how this is working. Anyone have any questions to what we did so far? Right? So everybody comfortable with using nested try blocks, right? Everybody understand why you use 3 try blocks. You use 3 try blocks because you have 3 input boxes, 1 for each input box. So if you have 4 input boxes, you use 4 try catch blocks nested. So that's what we have. All right, let's go ahead and run it and see how this works. All right, so I'm gonna go ahead and hide this display in here, and let's run it. So it's gonna, I'm gonna first try to input invalid values and see how this is gonna work. Right, to validate that these custom error handling are working properly. So I'm gonna put invalid value for runner 1 time, then invalid value for runner 2 time, and invalid value for runner 3 time, see that it will catch them up. So let's see how this works. So first thing is I wanna enter, for runner 1, I wanna enter an invalid value, right? So this is not a number, of course, right? It's not a number. So what's gonna happen is when it hit this statement, runner 1 time, is gonna throw it to the outer try catch block and display an error message that you cannot convert this thing to a number. So I tell you in here, basically enter numbers only for runner 1 time, okay? When you say okay, it's gonna put the focus on the runner 1 text box and it's gonna select the text. Here it is. So let's put in here that we have 1. And let's put for runner 2, again, put an invalid value. All right, it's gonna tell you again, the second try statement is gonna fail, right? Because it's gonna try to convert the value entered in the txt runner 2 text box, and it's gonna fail. It's gonna throw it to the catch block, and it's gonna select that. And I'm gonna put in here 2. Again, I want to enter invalid value for runner 3. is gonna fail. The third try block is gonna fail. Not gonna be able to convert that to an integer. So when you say okay, it's gonna take you there, and I'll put 3. So now everything is fine, right? So all 3 tries gonna succeed. So it's gonna go to steps 2. So you don't get to go do step 2 unless all the inputs is correct. So you go to step 2 where you're gonna compute the average. And basically, if you're gonna do the average in here, the average should be between 1 and 3, right? That should be basically. Let's go ahead and do a calculator and show you what the average is gonna be. Always, by the way, use a calculator to verify that you're gonna get correct result, right? So, okay, here it is. So we have in here 1 plus 2 plus 3, right? This is 6. You divide that by 3. We're gonna give you 2, right? The average should be 2, right? Let's see if we're gonna get 2. Give you 4. It's not correct. So we have a logical error, right? This is one thing in programming. Logical error are the difficult error to find, right? Because the compiler doesn't tell you where the error is. You have to find it, right? Trying to find logical error is called debugging, finding the error that why you're not getting the 2 that you expect to get, you're getting 4. How do I find this error? And in chapter 3 is not, you don't have much, you're not gonna get much logical error in chapter 2 because the flow of control is very straightforward, very simple. But when you get to chapter 4 and 5, you're gonna need debugging because it's gonna happen. You're gonna run your program, you're gonna get the incorrect result. And you're gonna say, all right, why I didn't get the correct result. Using debugging, and I'll show you debugging technique, can help you find the error. So let's go ahead and fix that. So we know that there's an error in the program. So let's go see how we're gonna fix that, right? To fix that, you can do what we call, you can put a breakpoint. In this case, it's a small program, but in real life, you may have programs that have thousands of lines, right? So you don't know where the error is in your 1,000 line of code. One way you can find it is by putting a breakpoint. I can put a breakpoint by going to the margin next to the first try block, let's say in here, and I click on that margin. It's gonna put a red dot and it's gonna highlight type. That means there is a breakpoint in here. What does it mean, a breakpoint? It means that when you run the program, when it hit this statement, line 9 is gonna stop. And it's gonna the system is gonna allow you to examine the content of the variable to see if the program is doing what you think it's supposed to do. Because sometimes you may think that the program is doing one thing and the program may be doing another thing. So always, I highly recommend, whenever you don't get correct result, don't assume anything, right? Don't assume anything. Put a breakpoint and verify that the program is doing what you think it's doing. Because many times you may be thinking one way and the program is doing something else, right? So you have to do that. And it happened with me. Sometimes I don't see the error and I have to put breakpoint to figure out where the problem is. So let's go ahead and run and see what's going on. Right, so I'm gonna run it in here. And I wanna step through the program step by step to make sure it's producing correct result, right? So I'll put the same number in here, 1, 2, and 3, right? The same number I did before. Let's say calculate. It's gonna run, it's gonna stop in here. This is called the breakpoint, stop at the breakpoint, all right? So what I'm gonna do in here, while I run it, I'm gonna examine the variables, right? To examine the variable, you can right click on each variable you wanna examine, like int runner 1. And from the shortcut menu, you can select add a watch. You can select add watch. And it's going to add a watch to the watch screen and it's going to display the value of it. Right now it have some, it's displayed in hexadecimal. I write program in assembly, sometimes I use hexadecimal. Let me, you're not going to see that on your code. I'm going to right click on and select uncheck hexadecimal. So it's showing me 0. So it have 0 value, runner 1 time, which is expected. We haven't done anything. All right, let's add a watch point for runner 2. Right click on it, add watch. It's going to show you runner 2 time is 0 also. Right click on runner 3, add watch. Okay, it's 0 also. Let's add the average. Right click on average, add watch. It shows you it's 0. So all of them, everything is 0. I haven't used them yet. All right, so let's go ahead and step through it. To step through it, you click on the step over button. There is step into and there is step over. Step into become handy when you start working about user defined function, which we're not gonna cover in this class. So always you're gonna click on step over. Click on step over is gonna go to statement at line 10. That's what's gonna execute that next. It haven't executed that yet. So notice the value of runner one time is still 0. But when I execute that, it's gonna grab the one from the form, and it's gonna place it there. Let's execute that. Step over. Right. Notice in here, as it executed line 10, the value of runner one time changes to 1, and you can see it in red. It changed it to 1, right? Which is expected to what happens. So it's doing okay. This is correct. Let's step over again. Now it's ready to execute line 12. When I step over it, here it is. The value of runner two times have changed to 3. So this is fine. It's working properly. This is what we expect. Let's do runner 3 now. And I step over it, it is 3. So this so far is working okay. So now we're ready to execute line 17, right? We know from the calculator that we use, right? We know that this should give us, the average should give us an average of 2. We know that because we tried it by a calculator and this should give us 12. Let's see if this is gonna give us 2 for average. I'm gonna step over it and you're gonna see it's gonna give us 4. So we know for sure that the error is in here. We know that the error is in line 17, right? So this is our error, is in line 17. Let's go ahead and stop the program. There's no point continuing. I'm gonna click on stop, the stop button in here, right? And I wanna look closely at line 17 to see where the error is, right? The error you're having in line 17 is because of the operator hierarchy. If you remember, division occurred before addition. Division have a hierarchy over addition. So this is dividing the runner 3 time by 3 first. Runner 3 time is 3. 3 divided by 3 is going to give you 1. Then it's going to add the other one. So it's going to add then the 1 plus 2 is 3 plus 1 is 4. That's why you're getting 4. To fix this problem, you have to do the additions before the division. The way you do that is by enclosing the sum in parentheses. By putting them in parentheses, is going to add these 3 scores together first, right? So 1 plus 2 is 3, plus 3 is 6. Then dividing the sum by 3. 6 divided by 3 is 2. We're going to give it the right result. So let's go ahead and try it again. I can remove the breakpoint. You remove it by click on the red dot again. This will remove it. Let's go ahead and run it and see if it will give us correct result now. And this is a simple example. We don't really need debugger. Probably most of you may have already figured that out when you saw that I didn't put the parentheses. But when you get to chapter 4, things are not going to be as obvious as this one. So I'm going to go ahead and put in here the same running time as before, 2 and 3. And do calculate, it should give me 2%, which is okay. Average is 2, so it's working okay. So the program is working okay, and this is how you do debugging. All right, debugging gonna become important in chapter 4, which we start with on Wednesday, because the program are gonna be more complex when you start with chapter 4. Anyone have any questions? All right, let's go ahead and save that. Save this thing, and I want to close this window in here, and we're gonna do just a PowerPoint presentation. So now that we have all the concept, we're gonna go over the PowerPoint presentation, which is how to do with variables and calculations. Right, so chapter 3 talk about variable calculations. This is an important chapter because this is the basis, the fundamental you need before going into chapter 4. You need to know how to store data into variables. We talk about whole numbers, we call integers. We talk about floating point numbers, we call double or decimal. So we need to store data in the right variable type. And we need to be able to do calculations, add, multiply, divide, subtract, all of that. That's why it's essential to know chapter 3. So let's go ahead and go over that. So there's lots of section here. Chapter 1 talk about gathering input. This is the text box, which you already know. You're very comfortable with it. Variables and data type. This is where you talk about different type of data. You can have whole numbers. We call them integers. You can have floating point numbers. We call them double and decimal. And you can have text data. We call them strings. So these are the data types, right? We're going to talk about performing calculation, right? Arithmetic operator, which is addition, subtraction, multiplication, and division. There's also exponent, and there's also remainder of a division. We'll talk about mixing different data type, right? What would happen when you mix integer and double? Sometimes you have a conversion. There are two types of conversion we're going to talk about. Narrowing conversion that would lose data, and widening conversion that doesn't lose data. So we'll talk about these. We'll talk about the formatting numbers and dates. This is using the toString method, right, to format the output. We'll talk about class level variable. This is the example we did when we had the coins and we had a coin counter to count the total. We had to use a global variable to keep the totals running properly. And then we talk about exception handling. This is a try-catch block, right? Everybody familiar with. And we'll talk also about using group boxes, right? So when we did the application about the room charge calculator, we had 3 group areas or group boxes, one for the room charges, the other one for additional charges, the other one for the total charges or for the output. And then we talk about the load event procedure. This is where we put the procedure to display the time, the date and time. All right, so we had to use the now function that return the date and time and format that using the toString method. And this is the last one, is a room charge calculator that we did. Okay, right. And then we talk about debugging also. So this is basically chapter 11. Right, so let's go ahead and continue with that. So section 1 is about text boxes. This is simple. Basically, in here, the important thing to remember, whatever you enter in here are text. So if you enter in here the string Joe, and you wanna display hello Joe, all right, what would be the code to do that? Right, so let's assume that the text box is called txt name, right? So, and the label is called LBL greeting. So what would be the code for the event handler that you need to put when you click on the greeting button? Let's look at that. So in here we have the label, the output is going to be LBL greeting, right? That text, right? And we're going to say hello. So this is an example of a string literal. String literal you put in double quote and you say hello. And maybe space after that. String literal mean literally what you see is what you get. So what's gonna display is hello. And that's what you're saying in here. In the first part of the output, you're saying hello. So literally you're gonna get hello. So it's called string literal. And you're gonna combine that. So we can use in here, and we're gonna combine that with whatever we enter in the text box. And let's say the text box is called txt name. Right? And if we enter Joe, this is to get that whatever we enter, you use the text property. Right? So this is gonna give you, this is called a this is not a string literal, but this is gonna give you basically whatever you enter that. This is where you're gonna get the Joe. Right? So when you combine these together, you're gonna say hello Joe. And this is basically your event handler. This is how you program this button. Right? So let's go ahead and see that. Okay. So we can use label to basically, you can assign the text property probably a text box value like we did in here. So you can do that. This will display whatever in TXT input. Or you can display it in a pop-up window by using messagebox.show and say TXT input.text. You can do that. If you want to assign the text box, if you want to clear the text box, okay, you can assign it an empty string. So you can say TXT input.text equals string.empty. It's going to clear the text box, right? But a better way to clear the text box is to use a clear method. You can say TXT input.clear. It's going to clear the text box. Now, the clear method is available to text boxes. It's not available to labels. So you cannot use TXT input.clear for labels. For labels, you have to say LBL input.text equals string empty, right? Notice in here the difference. The clear method have parentheses at the end because it's a method. Methods always have parentheses at the end, right? This is not a method. This is a property. It doesn't have parentheses at the end, right? So empty is a property. It doesn't have parentheses, but clear is a method. Okay, so here's the implementation of the statement I just showed you, right? Remember this thing? Right? LBL greeting that text equal hello, combine it with the TXT name that text is exactly what you have in here. LBL greeting that text equal hello, combined with the TXT name that text. This is a implementation. This is called the string concatenation, this %. It's called string concatenation. It allows you to combine strings together. This is the only operator available for strings or text, right? For numbers, you have addition, subtraction, multiplication, division, exponentiation, remainder. But for strings or for text, you have only concatenations. It's the only operator available. Right. Here's the example. We did that in the examples where we enter in here the day of the week, the month, the day of the month and the year, and we enter the value and we combine them together and display them. So we did the links example on that. Now, when you design the form, nice thing about Visual Studio, it allows you to align things vertically by using the guidelines, the blue guidelines, and horizontally by using the lavender guideline. So you can do that. Variables is important thanks to chapter 3. It allows you to store data. Variables are storage location in memory where you store your data. Because what you store in memory can change, that's why we call them variables, because their content can change. We call them variables. Of course, the variables are tied to a data type. So if you define a variable as an integer, you can store only whole number in that memory location. If you define a variable to be a double, then you can store floating point number on that memory location. But a variable is a memory location address whose content can change. That's why we call them variables. So a variable is a storage location in the computer memory, in RAM. That's where it is. It's used for holding information while the program is running. The information that is stored in a variable may change, hence we call it variable. Why you need variables, all right? You can see as we go with chapter 4, but you need it maybe to store values entered by the user so you can manipulate them. So instead of working every time you want to refer to the day of the week that was entered in a text box, instead of every time have to say txt day of week dot text, you can just store it in a variable, basically int day of week, which is shorter. So it make it easier to work with expressions this way. Sometimes you have to use variable to do arithmetic calculations, all right? You cannot do calculation with text boxes. You have to use variables, numeric variables to do that. Maybe you wanna do test values to determine if they meet some condition. We're gonna talk about that in chapter 4. You may have to make decision. If the is the hour you work, are they more than 40? If they are more than 40, then you have overtime. If they are not more than 40, you don't have overtime. So this is a test condition that we're gonna learn about in chapter 4. Maybe to temporarily hold and manipulate value of a control property. Maybe you wanna store the color property of a label in a variable so you can use it later on. And maybe to remember information for later use in a program. Anyway, there's variables is at the heart of a program. At the heart of any program are variables, because you have to work with data, you have to store the data in memory and RAM, and you need variable for that. So that's why chapter 3 is important, because this is where we learn how to store data in the computer memory and then do operation on the data, calculation, addition, subtraction, multiplication, etc. Right, how do you think with variable, about variable? You as a programming, you make the variable name, you give it a name, but you have to give it meaningful name. So don't name your variable meaningless name. Always give them meaningful name. If a variable represent the hours work, call it hours work. If the variable is a double store floating point number, call it maybe DBL gross pay. Use that so you know exactly about what the variable is. Visual basically associate that name with location in memory. The value currently associated with the variable is stored in that memory location. For example, let me give you an example in here. Let's say that you declare variable in here, and we did that in our programs. Okay, we've been doing that for a while. Let's say in here we declare in here an int variable called in here nights as integer. And if I want, I can assign it a value. I can say equal to 2. What does this statement does? It's basically it's going to allocate in RAM, in memory. It's going to allocate a chunk of memory, and it's going to name this chunk of memory. It's going to call it. It's going to name it int nights. Right? And it's going to store in this memory address the value you assign it to. Right? That's what happened. So a variable is nothing but a storage location in memory. It's in RAM. Right? So if you declare another variable after that, DBL miscellaneous as double equal 10.5. What's gonna do in here is gonna store another memory value, the value 10.5, and is gonna name this storage location. This memory location is gonna name it DBL miscellaneous. So variables are nothing but storage area. They are memory location where you store data. That's what it is. And you can, if you like, later on, use an assignment statement to change to int night, to change them to equal maybe 5. So if you do that, what's going to happen is going to change the 2 in here in memory, is going to change it to 5. And because the content of memory is changing, we call it a variable. That's why we call it a variable, because it doesn't change. It's not fixed. It can change at runtime. So we call it a variable. So variables are very important for programming, because this is where you store your data that you're gonna use to manipulate. So you can think of the Visual Basic associating with the name you use for the variable as a memory location. The value currently associated with the variable is stored in that memory location. So the 2 in here that we use, or the 5 we use, gets stored in the memory location. That's what it is. Okay. Here's an example. We're declaring in here a variable. This is the syntax, dem variable name as data type. Variable name is a programmer designated name. You can call it anything you like, right? Data type is one of many possible data type. The most common one is integer for whole numbers and double for floating point number, string for textual data, right? But there's other type. The convention is to name your variable using a prefix. So if you're gonna have an integer variable, use a prefix int. right? Depending on the type of variable, you need to use a proper prefix. So if you have in here variable type, like we use with control, and you're going to use a prefix. So if you have in here whole number and integer, you're going to use a prefix int. Lowercase, prefix is always lowercase, right? If you have a double variable, which we use for floating point numbers that have fractional part, you can use a prefix dbl. The author like to use W's have 15-digit accuracy. The author like to use decimal. Decimal have 28-digit accuracy, but you don't need that. It's overkill. For most application, you never need 28-digit. It is in a very rare application, you're gonna need 28-digit accuracy. Most of the time, 15-digit is more than enough. That's what I like to work with DBL. And you can have a string variable. This is the example that we did about the date. Using here str, right? And there's other data type ever, but for each one, you have to use a prefix with that, right? Remember, we use also prefix with the control, right? Right? So if you have a text box for input, use txt. If you have label for output, use lbl. If you have a button, use btn, etc. So we use these prefix. So prefix is always lowercase, all right? And you want to try to associate the prefixes with the name. So usually if you're getting an input from a text box and you call, like say, you call the text box txt nights, for example, you probably want to call the variable int nights. So use the same name, change only the prefix. Let's say use another, for output, you have lbl gross pay. So you may want to call in here for the output, called dbl gross pay. So use the same name, change the prefix only, right? This is what you see on the form, the control. This is the variables, right? But most of them are going to use prefixes, and you're going to stick by these naming convention, right? Always, right? Prefixes make it lowercase always. Right, so this is very easy to understand name. It tells you that this is an integer that represent the lengths. Very easy. As opposed if you call it XYZ, you don't know what the hell is that, right? But when you read this one, you know it's an integer that represent the lengths. So it's very easy to understand. Always you have to write, clarity is essential in programming. Keep in mind, developing program code is expensive and you have to change your program very often. And if your program are not easy to read, they are expensive to maintain, and nobody will hire programmers that create programs that are difficult to read. So you have to be very clear and writing clearly. Right, here's some, you need to declare variables. If you like, you can declare them all in one line like this one. So we're declaring 3 variables in here, int length, int width, int height, all of them as integer. I can do it in 1 line or I can do it in 3 lines, right? This is preferable because you don't want to get into the habit to declare too many variables in 1 line, especially then you'll have to scroll to see what the variables are. You don't want that. You want to declare them probably on multiple lines. The other advantage is if you want to initialize the variable, you can initialize them in here. You can say this one equal, all right, maybe to 10. But you cannot do that in here. You cannot say in here equal 10. This one doesn't work in here, but it works in here. So yeah, it's better to do it like that. So if you want to initialize it, you can initialize that. A Visual Basic initialize numeric variable to 0 by default, right? It is the only language that does that. Other languages like C++ does not initialize your variable, but Visual Basic does initialize them to 0. All right, the rules, I talk about that. You have to use easy to understand rules, right? The first character also should be a letter or underscore. You cannot start the name with a number, right? Subsequent character may contain letter, underscore, and a digit, but the first letter cannot be a digit, right? So keep that in mind. Use the common sense about naming. Use a prefix and meaningful name. The prefix will be lowercase letter. Every word after the prefix is capitalized. So the H in ours is capitalized. The W in ours is capitalized. This is called good programming style. If you write it all lowercase, it's called bad programming style. And guess what? If you send me a program that is written in bad programming style, I will deduct points. You have to learn how to write clearly. So you would write it using lowercase prefix and capitalize every word following that. Right? This is another one. So everything is easy to read when you use meaningful name, right? You can assign value to variable. This is called an assignment statement. It is not an equality. It's not equal. Intlinks is not equal to 112. 112 is assigned to inclinks. What's the difference? Let me show you the difference. When you do something like this, in math, if you say x equal x plus 1, this is in math have no meaning. You cannot do that, right? X can never equal x plus 1, right? But in programming, this is have perfect meaning. Remember, you have memory in here, and x is a memory location. Maybe it's 0, right? So you have in memory location x, you have the value 0. When you say x equal x plus 1, you're saying take whatever is in memory address x, which is this one, change, add 1 to it. So you're going to take in here, what's in it is 0, add 1 to 0, is going to change the 0 to 1, and store it back. So evaluate this expression, install the result back into x, or assign the result back into x. This is going to change that. It's going to add to 0, 1, make it 1, and store 1 into x. It's going to change x to 1, right? So this is called an assignment statement. Always the syntax is equal variable equal expression. This is a valid syntax. You cannot say expression equal variable. This is invalid syntax, right? So in other words, you can say x equal x plus 1, but you cannot say x plus 1 equal x. Okay, I say equal, but assign is not true. So this is not correct. So keep that in mind, all right? So you have to say the variable is equal to expression, not the expression equal variable. You have to keep that in mind, right? So keep that in mind. And this is have perfect sense in programming, have no sense in math. So it's not an equal, it's an assignment statement, right? Now, there is shortcuts. You can say x is equal x plus 1, which is incrementing x by 1. That's what we're doing. X was 0. When we added 1 to it, it became 1. So it's incrementing x by 1. There's a shortcut notation you can use. You can say, instead of saying that, you can say x plus equal 1. This is called a combined assignment operator. These are equivalent. Some people like to use a shortcut because it's less typing, and it's basically, sometimes it makes sense. You're incrementing x by 1. That's what it's saying. So some people like to use that. Some people don't like to use that, right? So anyway, so we'll get to that also. All right, so this is called an assignment operator. You can use it with numeric variable, like assigning 112 to the length variable, or you can use it in string variable, like assigning the combination good morning and the name of a person to the greeting string variable. So this is gonna say here maybe good morning, Joe, right? But in both situations, what you have in here on the left-hand side, you have a single variable. Always on the left-hand side, you have a single variable. You cannot have an expression on the left-hand side. Now, the data that you can store can be whole numbers. We call them integer. They come in variety, in different flavor, but they are all integers, right? All right. This is what we call a byte, which is only 8 bits in length. You have a short, which is 16 bits in length. You have a integer, which is a 32-bit in length. And you have a long, which is maybe 64-bit in length. All right. Depending on how big the number you're dealing with, you can use one or the other. But they all store whole numbers. That's what it is. You have a floating point number. Again, you have single, which are single precision floating point number. They can store up to 7-digit accuracy. They are accurate to 7-digit. Most of the time, single is not accurate enough, right? So if you want to store social security number, for example, it's not going to be enough to store that, right? Most of the time, you're going to use double. Double is 15-digit accuracy, which is for most applications is good enough. Now decimal give you 28-digit accuracy, which is give you more accurate digit. Depending what you're doing, you can use one or the other, right? But these allow you to store fractional number like 1.5 and other things. Integer cannot store fractional number. Then you have other type. Boolean, we're going to talk about it in chapter 4. These are these variables that can have one or two value, either true or false. These are good in decision making. That's why we need it in chapter 4. Character can store a single character. String can store a string of characters. And date can store date and time. All right, so these are the different variables we can use. Here it is. Here are the different variable. Byte allow you to store numbers that range between 0 and 255. Right, unsigned number. You cannot store negative number. If you can store negative number, you cannot use byte. Short allow you to store numbers between minus 32,768 and plus 32,767. Now, if you want to store social security number, you cannot store it in a short, right? Because it doesn't accommodate that much digits. Now, integer can store number between minus 2 billion something to plus 2 billion something, right? This should be good enough for social security number, right? And if you want even longer than integer, you can use long integer, which can store you enormous, huge numbers, right? So most of the time, integer is what you want to use. So that's why in this class, we always, for whole numbers, we're gonna always use integer, right? For this class, always, whenever you have a whole number, don't worry about the other type, declare them as integer. Because for most application, it's enough to do what you need to do. Floating point number, as I indicated, you can have single precision, you can have double precision, you have decimal precision. The single precision gives you 7-digit accurate. I mean, it may tell you can store number up to 10 to the power 38. That means 38 zeros. That's what I mean in here. But only 7 of them are accurate. The other are zeros. With double, you can store number with up to 300 zeros, right? 380, but only the first 15 are accurate. The other are zeros. With decimal, you can store number up to 29 digit, but all the 29 digits are accurate. This is double precision. This decimal precision. Again, depending what you're doing, you would use a type. Most application, double is good enough for most application. Boolean, other type Boolean is, we're going to talk about it in chapter 4. It can store one or two values, true or false. This is to make decision making. It's like flag. You can use it to go one way or another. Character is a variable that stores a single character. The prefix is CHR, by the way. For Boolean, prefix is BLN. It can store a single character. String can store a string of character. Prefix is STR for variable name. Date can store date and time. Prefix is either DAT or DTM, date and time. All right, Here's some example. We're declaring in here is a variable str name to represent the name of a person, and we can assign it the value Jose Gonzalez. So what gets stored in memory in that variable name is Jose Gonzalez. If you want to clear that value, you can do it in two ways. You can assign it an empty string, which is two double quotes with nothing in between. It's called an empty string. There's no blank in between. This is an empty string. Or you can just use a constant string empty. So either one, these are equivalent. You can use string.empty or you can use two double quote. They do the same thing. Dates, you can assign date variable a date or a time or a combination of date and time. Here's an example, DTM birth. You can assign it the date May 1, 2010. You enclose the date literal between £sign or hashtags. You can assign it if you like time only, like 8:45 p.m. Or you can assign it date and time, like 10:20, 2010, 6:30 a.m. You put that between hashtags. Right. For strings, you put double quote. For dates, you put hashtags. All right. Here's an example of using concatenation operator with string variable. So I can say the full name is equal to the first name dot text. Combine that. This is a concatenate operator. Combine it with a blank. Combine that with a last name. And this is going to give you the full name of a person, like Joe space Doe, for example. And then you can assign this string variable, if you like, to a label, to the text property of a label, to display it on the form. Now, very important, we said Visual Studio, as soon as you start typing thing in Visual Basic, IntelliSense will kick in. So if you're trying to type the control name, IntelliSense will show you the control. Or as soon as you start typing a variable name, IntelliSense will show you the variable name. The rule is this: as soon as you see the variable name you want or the control name you want, press on tab. Don't type the whole thing. The reason is not only you saving time by using IntelliSense, so you type less, but more importantly is that you prevent typing errors. If, for example, you type a variable name incorrectly, you're gonna get a bug in your program. You're gonna have an error in program, and then you have to figure out what went wrong. By using IntelliSense, you don't have to worry about that. So always use IntelliSense. Variables are initialized in Visual Basic. Most programming languages do not do that. C++, when you go take a next class in C++ or Java, C++ and Java are not going to initialize the variable for you. That's how variables are initialized in Visual Basic. Numeric variables are initialized to 0. Boolean variables are initialized to false. The only exception is string variables. String variables are not initialized. They are initialized to nothing. That means they are not initialized. Date variables are initialized to midnight, January 1, year 1. Because string variables are not initialized, nothing is not initialized. It's a good idea when you declare your string variable to initialize them to an empty string. The reason why it's important to do that, because if you try to access the string name without initializing it, is going to give you an error. So always initialize it when you declare it. So the value nothing will cause an error if used. You can initialize variable when you declare them, like we did in here. So if you want to set the months per year to 12, you can declare it them in months per year equal as integer equal to 12. This will initialize the value stored in that memory address to 12. Now, variables declared inside a function are called local variables. So variable declared outside a function are called global variables. For most application, you want to declare your variable locally. right? So the scope refers to the part of the program where a variable is visible. Maybe accessor, which is where the program may access it. So if you declare a variable, let's say in here, let's say we have a program. And so if you remember from the structure of the form we create, the first thing you're going to see in here, you're going to see class form1, right? And you can have in here, you can declare if you like some variable in here. We can say in here them, and I can see in here int total as integer equal to 0, right? I can declare in here, you can have in here a subroutine, and let's call it in here procedure 1 or proc1. And in here I can declare, I put another dem statement, and I can put in here a, b as integer. And I have different stuff in here, and then we have and sub. And we have another subroutine in here, proc2. And in here I can have another, I may have another dem statement. I say dem in here xy as integer. And I have different statement here, and then we have and sub. All right. And then you have in here and class. So what you have in here, you have two subroutines or two procedure inside the class. This is your class. And inside of this class, you have two subroutine. Now, the in total variable, this is global or class level. In a sense, it's global. Right? So this is class level or global. These, on the other hand, let me use different color. These, on the other hand, are local. Local variable. And this is local variable. What does it mean, local and global? What it means in here is in total can be accessed by any procedure in the class, in the form. So you can access in total, you can access it in proc1. So you can say in here in total plus equal 1. So you can do that. You can access it in here in total plus equal 1. So you can access it in any place. So you can access it in procedure 1, you can access it in procedure 2 because it's a global variable. It can be accessed anywhere. But in here, A, B are local. They are local to proc1. That means you can use them only in proc1. You can use it up to the end sub for proc1. Outside of end sub for proc1, you cannot use them. So you cannot use A, B in here in proc2. So A, B cannot be used in proc2. They can use only in proc1. Similarly, XY cannot be used in proc1. They can be used only in proc2. That's what local mean, right? And many of you will say, all right, if I want to choose between the two as a beginner programmer, you may say, oh, I want to do the global, right? Because I can be everywhere. And you think that this is better, okay? But actually, it's a bad idea. It's a bad idea to use a global variable because the more scope you give a variable, the more possibility of getting bugs in your program. So in other words, think about it. If you have a program that is 10,000 line of code, and if you make a variable available to every line of code in this 10,000 line of code program, then finding the error is going to be difficult because you have to search these 10,000 line of code to find where the error is, right? But if you limit a variable to only one procedure, then you're not going to have bugs in your program because the scope of this variable is limited to a small amount of code, so it makes it better. So as a rule, variables you don't want to declare globally, you want to declare them locally as a rule. So this is basically the idea of that. All right, so anyway, this is, okay, I have the wrong one. Here it is. Okay, so we have that, so local variables. Performing calculations. You have arithmetic operators. This addition, subtraction, multiplication, division is exponentiation. Everybody knows about all the operation. Multiplication is exponentiation is raising to the power, right? What does it mean? Let's go ahead and do an example of that. Right, exponent. Okay. So in here, if you say in here, 2 to the power 3, right? This is equal to 2 times 2 times 2 3 times. So this is the base, and this is the exponent. So in here, you're going to multiply the base by itself 3 times because the exponent is 3. This is how you compute it. So you have that in Visual Basic. So you can use that. Right. So let's go ahead and look at this. See some examples. You can do the addition to add to the price to tax, subtraction to subtract from the price to discount, multiplication to multiply the lengths times the widths to get the area, division to divide the total by the number of items to get the average, exponentiation to get the volume of a cube by multiplying the side, raising the side to the power 3. So these are all calculations. Now, in addition to that, you can use integer division. Integer division is the backslash, right? What's the difference between the two? Let's go ahead and look at an example. There's a difference between the two. You can, for example, if you take 5 divided by 2, right? This is going to give you 2.5. This is floating point division. If you do 5 divided by 2, integer division 2, this is going to give you integer division. It's going to give you 2. It doesn't give you the fractional part. So it's going to give you 2 remainder 1, right? Because 2 times 2 is 4, and you have 1 left. 4 plus 1 is 5. Now, to get this remainder, use a mod operator. Mod 5, 2 will give you the remainder of 1. Give you the remainder. The remainder, you get it using the modules operator. Modules, we call it the remainder operator. So usually, these two operators, use them together. And the mod, you use them together. So use together, right? Why you need to use them together? Let's say that we have 35 ounces. All right. Everybody know that 1 pound is equal to 16 ounces. Let's see basically how many pounds and ounces is equal. So you can do that by saying in here 35 integer division 16, right? This is going to give you 2 pounds. And then you can take this one, mod 35, 16. This is going to give you the remainder of dividing by 16, which is going to give you in here 3. So 35 ounces is 2 pounds and 3 ounces, right? So it allows you to convert from one number system to another. So it's going to give you 35 is 2 pounds because 2 times 16 is 32 plus 3 ounces 35. So this many times you may want to display this one like this. So use this integer division and mod operator, use them together to do that. Use it also to convert maybe how many hours, minutes, and seconds you have in a certain amount of seconds. or how many quarters, nickel, dimes, and nickels and pennies you have in a certain change amount of coins. So use that to do that. Okay, anyway, so so these are some of the operators. So this is integer division. So if you divide in here, in minutes have 190, this is going to give you 3, because 3 times 6 is 180, and you have a remainder of 10. You can do this thing with 16 mods 3 is going to give you basically the remainder. It's going to give you basically when you take 5 times 3 is 15, you have a remainder of 2. So the remainder is 2. This one is allowable in C++ and Visual Basic, not in any other programming languages. You can have a remainder of floating point remainder. Both the integer division and the modulus operation can return a divide by 0 exception. So keep that in mind. If the numerator, in other words, if the denominator is 0, you're gonna get they're gonna throw a divide by 0 exception. This will be caught by the try-catch block. All right, you can get the current date and time using the now. The now will give you the current date and time. The time of the day will give you only the time. Today will give you only the date. You can use this thing. You can do x equal x plus 4, x equal x minus 4. Basically, you're increasing x by 4. You're decreasing x by minus 3. You're multiplying x by 10. You can do shorthand notation for all of them if you remember, like we did. So instead of saying x equal x plus 3, this is you're increasing x by 3. You can say x plus equals 3, right? Instead of saying x is equal x minus 2, this is decreasing x by 2. You can say x minus equal 2. So these are equivalent, and these are equivalent. This is called a combined assignment operator, so you can use that. This is what it means. Or here, instead of saying in here x equal x plus 2, you can say x plus equal 2. Instead of saying x equal x minus 5, you can say x minus equal 5. Instead of saying x equal x times 10, you can say x asterisk equal 10. Similarly, we can use it with the division, floating point division, integer division, and concatenation. Also, you can, instead of saying a is equal a concatenated with b, you can say a concatenate equal b. So you can use that. So these are shorthand notation called combined assignment operator. It can save you typing, and some people like it. But if you want to use them in simple expression. Do not try to use them in a complex expression. All right. When you have multiple arithmetic operator, there is order of hierarchy. Remember when we tried to compute the average, we didn't get the correct result because multiplication and division are evaluated before addition and subtraction. So you have a hierarchy. The hierarchy is first you do the exponentiation, then multiplication and division, then you do the integer division, then the remainder, then lastly you do the addition and subtraction. Right. That's all what I have for today. On Wednesday, we're gonna start with chapter 4. So we'll finish this thing and then we'll start with chapter 4. That's all what I have. I'm gonna go ahead and stop the recording. After I stop the recording, I'll take any question that you have.